Hi everybody, hope you're all doing well. Today we're going to be introducing the topic of correlation and regression. Now if you remember back from right before your first exam, we introduced the idea of a statistical study, both observational and experimental. And in statistical studies, we sort of introduced the idea that oftentimes in statistics, when we have several different statistical variables, we want to understand if those variables are related. And correlation and regression is our first attempt at doing this. So if you look here, we can see that the sort of goal, or to summarize it, is that we're going to be attempting to understand, visualize, measure, and use the relationship between two quantitative variables. Now you will notice that we're calling special attention to the idea of quantitative variables. So what you should take away from this is that everything we're going to be doing, at least for the next couple lectures, is going to focus on pairs of quantitative variables. And we'll develop some different visual displays for these quantitative variables. We'll see how to measure their relationship. And ultimately, if the variables are related, hopefully we'll learn how to use the relationship between those variables to do things like make predictions or to make decisions. One quick note that we want to sort of draw attention to as well is that in our language of statistical studies, we often spoke about explanatory and response variables. We're going to continue to use that language, but oftentimes you will also hear the explanatory variable referenced as independent, and you'll often hear the response variable sort of referred to as the dependent variable. The terminology is interchangeable. We'll generally try to stick with the explanatory and response terminology, but sometimes you will hear it referenced as independent and dependent. So the first thing that we're going to discuss is how to visualize information where we have two quantitative variables measured about every individual. And the visual display that we're going to be using in our class is what's called a scatterplot. Now, a scatterplot is pretty simple. It's very similar to some of the XY sort of plots that you guys have already drawn in like classes like an algebra class or something like that. So we're just going to go over a couple basic rules with it. With a scatterplot, you're going to be drawing generally a coordinate axis. Usually we'll get away with just a single quarter of a coordinate axis. We're always going to have our explanatory variable on the horizontal and our response variable on the vertical. Then, of course, we're going to need a scale for each variable. So there'll be some sort of scale down here, and there'll be some sort of scale here. All right. Now, the explanatory and response variable can both have their own sort of scale. So the explanatory variable might be going by 5s, and the response variable might be going by 10s or 20s. Unlike some of the other displays that you guys have done, this is not a display that is entirely based around the verticality. What that means is that it is okay if the explanatory or the response variable their axes don't necessarily need to start at 0. So, as we'll see in some examples of that, if you don't start one of the axes at 0, what you will do is you'll sort of use a little squiggly line like that, and that indicates that the axis has been condensed. And that'll be useful when we don't start one of the axes at 0. And we'll see some examples of that as we start to build our own scatter plot. Then, once you have your sort of display ready, the actual scatter plot itself is going to be, as its name implies, a scatter of different points. So you'll have points that'll show up on this scatter plot. Maybe we'll just plot a few sort of random ones, right? So you'll get a scattering of these data points. And each of these data points, if you take that, right, this is an ordered pair, right? And it's going to be the explanatory variable, comma, the response variable. So just as a note here, right, what you should keep in mind is that each individual has two variables measured about them. So in our sort of data sets that we're going to be having here, every individual in the sample or the study is going to have two values recorded about them, one for the explanatory and one for the response. So that's the idea of a scatter plot. And of course, in a little bit, we'll be talking about how to build our own scatter plot once we have some data. But before we get into that, we're going to talk a little bit about what are we looking for when we're looking at these scatter plots. So there's going to be three things that we want to try to measure or understand when looking at a scatter plot. The first is the direction of the scatter plot. We're going to be looking for a couple options here. One is that we will look for scatter plots that display a positive direction. A positive direction means that generally, if we see increases in the explanatory variable, then we also are seeing, again, generally, increases in the response variable. So that would be a sort of positively directed pattern. A negative direction, or a negative pattern, means that as we see increases in the explanatory variable, we generally see decreases in the response variable. So in other words, as one of the variables goes up, the other variable goes down, and that's what we mean by a negative direction. Then we're going to have sort of a catch-all for things that do not have a single direction. These two directions are what are called monotonic, and that just means single direction. Everything else we will sort of reference as non-monotonic. And all this basically means is not always positive/negative. And we're not going to study non-monotonic scatterplots too much, but we do just want sort of a term as a catch-all here. For form is going to be sort of what shape the pattern is taking in the scatterplot. And once again, we're going to have a couple basic categories that we're going to be looking for. So the first and simplest, which is going to be the one that we're going to spend most time with, is going to be what's called linear. And of course, a linear scatterplot just means that the sort of pattern looks like a line. So we're going to be seeing something that looks like that or like that. Now, obviously, my first sort of line is positively directed and my second line is sort of negatively directed. But notice that in a line, it always has one direction. So words like positive or negative apply when you have a linear form. Similar to a linear form, and also very important, is what's called an exponential form. This means that the sort of pattern has a curve to it. In other words, it sort of looks like an exponential graph back from algebra. So that could be something that sort of looks like that, or it could be something that looks like that, or like that, or, perhaps even something that looks like that. My first two here would be positively directed exponential forms, and the last two would be negatively directed. You'll notice that they're a bit different than the linear ones because instead of having sort of a constant rate of change, a constant slope, they actually curve, and that's what separates a linear from an exponential. Finally, once again, we'll sort of have a catch-all category for everything else, which will be nonlinear. Now, this is sort of a bad name because obviously exponentials are nonlinear, but we're going to sort of designate exponential as a very special type of nonlinear, so it gets its own category. Nonlinear is going to be for everything else. So this is for a pattern that does not fit the above. So that could be things that maybe form like a U shape. That could be things that form like some sort of weird, almost like S shape, anything like that. And you'll notice that the nonlinear patterns that we're drawing, like that U shape or that weird sort of sideways S, those don't have a clear direction. So you will notice that non-monotonic and nonlinear sort of go hand in hand. Anytime we talk about something being a nonlinear pattern, we're expecting that it's non-monotonic, because if it was monotonic, we would hopefully be able to describe it as either linear or exponential. Finally, for strength, this is going to be one where we actually give sort of a definition. So definition, strength is how closely the data follows the pattern. Now, that'll be sort of, that should sort of sound like a vague definition, and it's sort of intentionally vague because with strength, we are going to learn a mathematical way to actually measure the strength. We're not quite there yet, so we're not going to say too much more, but we will learn an actual mathematical way to measure strength. Do keep in mind that right now, visually, strength is hard to say because we don't really have a reference point. So oftentimes when we're visualizing, all we will be able to do is say that this pattern looks stronger or looks weaker than another pattern. But in a little bit of time, we'll be able to actually formally measure the strength. One last sort of note from all of this. All of the terms above apply when there is. Well, there we go. There's a little mistake there. Let's go ahead and just erase that. Yep, well, now we erased way too much. Let's just go back and erase that whole note. This is bold to go ahead and do a note like that, but let's go ahead and try it in again. So our note is just simply going to say that these terms apply when there is a pattern / relationship. There is always the possibility of no relationship. And of course, what we mean by that is that if you see a scatterplot that is just completely scattered, well, that indicates that there really is no relationship between the variables. If there's no relationship, we wouldn't talk about the direction, we wouldn't talk about the form, because again, there's nothing to describe, and of course, the strength would be non-existent, because there is literally no pattern. Let's put all this stuff together and look at some examples of matching some variables with some scatterplots and describing those scatterplots. So, for this example, what we're going to do is we're going to take a look at each of the following pairs of variables. And as we do this, you should keep in the back of your mind that each one of these pairs is indeed a pair of quantitative variables. Because again, right now, our attention is exclusively on quantitative variables. So we're going to try to look at each of these pairs of variables. We're going to figure out which one should be considered explanatory and which one should be considered response. Then we're going to match the pair of variables with the most likely scatterplot sort of shown below. And then once we've done that, we'll try to describe that scatterplot, at least as best as we can, with the sort of terminology we have thus far. So let's look at this sort of first variable here. We have hours studied, clearly quantitative, and score on an exam. So we're sort of discussing here, what is the possible relationship, if any, between the hours somebody studies and the score that they sort of get on an exam. So if we take a look at this, right, if we're thinking about explanatory and response, we would expect that the hours studied here, this would be your explanatory, and the score on an exam would be the response. We're saying that if there is a relationship between these two variables, we would expect the hours studied to help explain the score on the exam. Is it the only factor that explains the score on the exam? Certainly not. But in this pairing, this would be how we would associate explanatory and response. Which of these sort of diagrams maybe makes the most sense for that pairing? Well, we should probably see that this would be associated with scatterplot number 3. If we look at scatterplot number 3 and we imagine that this would be hours here and this would be score, what we're sort of seeing is that generally as the hours of study increase, the score also increases, which seems to make sense. We would generally expect that the more somebody studies, the better they would do. What sort of ways would we describe this? Well, we already sort of mentioned it. This would certainly be positive. What sort of form does it have? Well, if it has positive, we can actually discuss a form like linear or exponential. Certainly, it's not going to be linear because as you can sort of see, it curves as it goes up, right? Initially, it's very steep, but later on, it becomes to be much flatter. What that indicates is that there's sort of a change in the rate of change, and that means that this guy should be viewed as exponential. Finally, in terms of strength, you'll notice that the points are pretty closely adhering to that pattern. So this guy would probably be pretty strong, right? What is this saying overall about the sort of variables? Well, what this is saying is that as the hours increase, the score also increases. But those sort of initial hours you study are very beneficial. That's why the slope is sort of very steep at the beginning. But later on, once you've studied a bunch, the rate of increase is much less. So it makes a big deal if you only study 1 hour versus maybe 3 hours, but it doesn't make as big of a deal if you study, say, 15 hours versus 16 hours. And that should make sense. That's what a positive exponential graph is sort of telling us. All right, let's go back and look at B now. So in B, we've got the number of visitors at an amusement park and the daily high temperature. So we're trying to see how these two things would be related. Here, we would expect that the daily high temperature would be the explanatory, and the number of visitors, right, that actually show up that day is the response. It wouldn't make any sense to say that the visitors explain the temperature, but it might make sense to say that the temperature explains the visitors. What graph would this be associated with? Well, probably most likely it'd be associated with graph 1. Let's see why that is. If we put the temperature here, because this would be what we're considering explanatory, and the number of visitors here, what we're sort of saying is when the temperature is very low, right? And if the temperature is very low down here, you don't get that many people showing up. Maybe it's not particularly nice weather to go. As the temperature increases, more and more people begin to show up. However, at a certain point, if the temperature gets too high, if the weather is too hot outside, then it begins to decrease. And that would seem to make sense, right? Most of us like going out when the temperature is sort of a nice, moderate range. If it's way too cold or way too hot, the number of visitors is going to decline. So that's what we're seeing in that first scatter plot there. How would we describe this? Well, you'll notice that since there's sort of a bend in it and it goes from going up to going down, from going positive to going negative, this guy would be non-monotonic. And all we mean by that is that, non-monotonic means that there is no single shape to this thing. It starts off by going positive and then becomes negative. So if we wanted to make a little note, it's positively directed and then negatively directed. What else can we say about this guy? Well, since it's non-monotonic, we can certainly say that it's non-linear, right? We can see that sort of upside down U shape there. And, it's pretty strong, but maybe not quite as strong as the last one. So we'll sort of still keep this as being relatively strong. And again, we're sort of saying strength just visually. Those points do seem pretty tightly around that upside down U shape. Let's look at C then. Selling price of a pizza and the number of pizzas sold. Again, there could be a lot of factors that go into this, but this first guy should be the explanatory and the second guy should be the response. In other words, as you change the price of a pizza, that may impact or explain the number of pizzas that get sold. So, which display makes sense here? Well, we should be associating this guy with the second scatter plot. So, this would be the price here, and this would be the number of pizzas sold. So what is this graph saying? Well, this is saying that as the sort of price increases, right? Initially, if the price is very low, lots of pizzas will be sold, which makes sense. It's cheap. If the price is very high, not as many will be sold because it's more expensive and people don't like paying for those expensive things. So that makes sense as the relationship or the potential relationship between these variables. This guy would be described as negative. This time you'll notice that the rate of change doesn't really change. There's no bend in it, so this would be considered linear. And considering that there is some fluctuation, you'll notice that the dots are not perfectly along that sort of line. Right, this guy could be sort of viewed as medium strong. He's certainly not as strong as the previous two. And again, we'll learn a measure to deal with that, but for right now, visually, definitely not as strong as the other two. Finally, we'll go up to D and we'll see that we're trying to look at IQ score and height. Now, probably a lot of us suspect that these are unrelated, and that's definitely the case, but let's imagine if we were investigating that, what would we say is explanatory? Well, it doesn't make sense to say that your IQ explains your height, because if you think about it, height is going to be something that's sort of preset for people, and you are the height that you are. So, if that's the case, we'd probably be expecting that height is the explanatory, while IQ score is the response. And of course, by process of elimination, this is associated with scatterplot form. So, if we put height here and we put IQ here, what are we sort of seeing in this scatterplot? Well, notice that down here, we're seeing some sort of people that have a low height, so are shorter, and generally have a low IQ. But over here, we're seeing people that are much taller, but also have low IQs. Here, we're seeing people that are very short, but have very high IQs. And here, we're seeing people that are very tall and have high IQs. In other words, height and IQ don't seem to be related. In other words, this, a completely scattered scatter plot, is exactly what we mean by no relationship. So when we're not seeing any sort of pattern in there, we're simply saying that those variables are unrelated. Now, when we come back into our next lecture, we'll take a look at how we actually build our own scatterplot and how we measure the strength.